Without an understanding of the mole, you can't understand concepts such as molarity, stoichiometry, the ideal gas law, equilibrium, and many other things. The mole is also useful because you can convert moles to almost anything, such as grams, particles, etc. The mole is considered the chemist's dozen, and it is 6.02 times 10 to the 23rd, also known as Avogadro's number. To find the molar mass, what you do is you find the mass of each single element using the periodic table, and then you add the masses of each element to find the molar mass. In the first example, we take the chemical formula PbOH4, which is lead 4 hydroxide. To find the mass, first we find the mass of each single element. The mass of Pb is 207.2. The mass of oxygen is 16 times 4 add 4, because the oxygen is being multiplied by 4. And then the mass of hydrogen is 1 times 4, because hydrogen is also being multiplied by 4. And so, to find the mass, the molar mass, we add them all. In total, that is 207.2 plus 64 plus 4, and the answer is 275.2 grams.
Funny videos. I can't be funny today. I feel like all the good videos.
Has to be like the color.
Find the molar mass of the following: PbCl5.
Did you wish I had gotten that? It's a towel. I mean,
plus H2SO4. The first step is to find the mass of each element using the periodic table. The mass of lead is 1 atom because there's only 1 atom of lead, multiplied by 207.2. The mass of chlorine is 5 atoms, because there are 5 atoms of chlorine, times 35.5. The mass of hydrogen is 2 atoms times 1. The mass of sulfur is 1 atom times 32.1 grams. The mass of oxygen is 4 multiplied by 16 grams. The second step is to add the mass of each element or compound to find the molar mass. So this is equal to 207.2 plus 177.5 plus 4 plus 32.1 plus 64. Yes, and it's 2 grams, not 4. That was my fault. And so the total molar mass is 482.8 grams per mole. Feed the post.
Are you good? Are you good?
Now we're going to do percent composition. Percent composition is fairly similar to molar mass. The first step is to find the mass of each element using the periodic table. The second step is to find the molar mass of the entire chemical formula. And then the third step is to divide each individual mass by the total molar mass. Multiply that decimal by 100, and that is your percent composition. So we're going to start with a basic formula, PbOH4, otherwise known as lead 4 hydroxide. The first step is to find the mass of each single element. The mass of lead is 1 atom, because there's 1 atom of lead in the chemical formula, times 207.2, which is the molar mass of the element. The mass of oxygen is 4 atoms, because the oxygen is being multiplied by 4, times the mass, which is 16. The mass of the hydrogen is 4 atoms multiplied by 1. Next, you add all of these values to get 275.2 grams as the total molar mass. Next, you divide each individual mass by the molar mass, multiply by 100 to get the percent composition. The percent composition of lead is 207.2 divided by 275.2, and that equals 0.753, which is about 75.3%. The percent composition of oxygen is 64 divided by 275.2, which is approximately 0.236, which is 23.6%. The percent composition of hydrogen is 4 divided by 275.2, which is equal to approximately 0.015, which is 1.5%.